Many years ago, I used to watch debates between people on the topic of evolution. One of the things I noticed then is that the people arguing against evolution often pointed out something simple to debunk the theory of evolution. They just point out that it's a theory. I would have ignored it if not for the fact that I kept on hearing that criticism of evolution in many other places from all sorts of people. I was young, biased against evolution, and not educated. But despite all that, I wanted to know more about this theory business. After all, why would educated, smart people not understand that simple logic of not banking on just a theory? It took me a long time to gradually learn and know better. This video is about me sharing some of what I learned and know to help save you the years of ignorance and associated embarrassment. I'm confident that by the end of the video, you will fully understand why in science, a theory is not a trivial matter. The scientific world has spent ages refining their craft and finding the best methods to discover more about how things work. In that journey, they learned many useful things. For example, they discovered that raw facts on their own, while interesting, are not all that useful. What makes them more useful is when you try and understand the relationship between those facts. To understand that, consider the following facts. Gas particles move around. They can be heated or cooled. Hot and cold gases behave differently. You can contain the gas inside something to change its behavior somewhat. Unless you enjoy random trivia, there's not much utility to simply observing and noting down those facts. The way we take our understanding to the next level from here is by studying the relationships between these discrete facts. That's how we end up discovering laws. For example, Charles' law states that if you keep the pressure constant, the temperature of a gas is directly proportional to its volume. As you can see in the simulation on screen, heating or cooling of the gas makes the volume get proportionally bigger or smaller. How about another law? Boyle's law states that if you keep the temperature constant, pressure will be inversely proportional to the volume. As you can see on screen, the pressure reading on the gauge maintains that inverse proportionality with the volume, meaning reducing the volume makes the pressure go up and increasing it makes it go down. For these laws, we can do the math and prove that these relationships are true. Laws, therefore, are essentially us detecting patterns in nature. And now that you understand that, let me ask you one very important question about these laws. Why do these laws exist? If you've ever wondered about things like that, you intuitively recognize the next thing in the hierarchy of knowledge, and it's called theory. To recap, we started with the random facts and observations about gases. Then we studied them to detect patterns in their behaviors. We labeled those patterns laws. But what we noticed is that a complete picture was missing. A theory is that which steps in to try and complete this picture. Realize that the few observations we talked about are not the only ones out there. The few related laws we spoke about are not the only ones out there either. So it stands to reason that if you wanted a more complete picture, you need to somehow weave all of these facts and laws together into one coherent image. An image that explains the sum totality of the body of knowledge we have on this subject. Now, given that it is science we're talking about, that something must explain all these facts and laws while still being testable and falsifiable. In other words, a scientific theory will not only explain the why behind those things, it must also make predictions that we can test to potentially disprove it. It must be testable in this way. Otherwise, saying it works by magic to any and all scientific questions we have will become a valid scientific theory. Going back to our gas examples, the next level up beyond the laws we talked about is the kinetic theory of gases. The theory proposes a number of things about the nature of these particles, heat, and energy, which explain and complement what we know while remaining perfectly testable for validity. This is the key realization that changed everything for me. My knowledge of the English language many years ago misled me into thinking that when scientists were talking about the theory of evolution, they were talking about what they think might have or could have happened. Sort of a guess. So at the time, it made perfect sense to me that anti-evolution folks were fighting back against that sort of garbage and pointing out that it's just a guess. But once I actually educated myself on the subject, I realized that the truth is quite the opposite. When we use the word theory in everyday English, we use it to mean something like a hunch or a guess. But consider the examples we discussed earlier in the video where we started from facts and observations, then laws, and finally development of a theory. Does that seem like guesswork to you? I hope not. This is how you get cell theory, germ theory, general theory of relativity, special theory of relativity, theory of gravity, etc., etc. Clearly, you don't think that scientists consider these subjects to be mere guesswork, do you? In science, putting theory of in front of gravity doesn't imply that scientists don't take gravity seriously. And therefore, anyone trying to discredit evolution by banking on this misunderstanding of the word theory is either evidently ignorant at best or maliciously dishonest at worst. Thank you for your time. Please don't forget to share your thoughts on the matter in the comments section. You can also show your support for content like this by liking and subscribing to this channel. This has been The Scientalist. See you in the next video.